Welcome to our channel. In this session, we will move to the program balanced binary tree. You know the meaning of binary tree. What is a binary tree? In which each and every node contains a maximum of two children. That means it contains zero child or either left or right one child or both the left and right child. Here the condition is you need to determine if it is height balanced. What is the meaning of height balanced? Read the question. A height balanced binary tree is a binary tree in which the depth of the two subtrees of every node never differs by more than one, means the difference between the left subtree and right subtree of a node is not more than one. For example, coming to node 3, what is the left subtree depth? 1. What is the right subtree depth? 1 and 2. What is the difference? Minus 1. Left to minus right. Suppose here 1 minus 2 minus 1. For node 3, there is no problem. For node 9, left to 0, right 0, no problem. For 20, left to 1, right 1, 1 minus 1, 0, no problem. Now this tree is a balanced tree. How they are given the input? Observe, they given the input like this. First 3 followed by their left and right. 3 followed by their left and right. Now the left and right of element 9. For 9 there is no left and right filled with 9. 20. Left is 15, right is 7. Similarly, for node 1, what is the depth? 1, 2, 3. For right, 1. 3 minus 1, 2. So here the tree is not balanced tree. So the output is false. You got the point? The difference between the depth of left subtree and right subtree is not differ by 1. Anyway, for the last case, root is equal to empty means there is no left subtree and no right subtree. Obviously, the output is true. Here, we will do the program like this. What is the first step in doing the program? Here, you need to calculate the heights. Yes or no? The main aim of this program is calculate the heights of left subtree and right subtree. Now, here I will write down one more function to calculate the height. Suppose my function name is def. Use the same term height of what is there given? Self comma root optional tree node. Self comma root optional tree node. Here I am taking one node value. Okay. For that node, I am calculating the height of their left subtree and right subtree. Anyway, first condition, if not node, what is the meaning? There is no node. If there is no node means simply written 0. Now, use some parameter LH. LH specifies the height of left subtree. Now, I am calling the function recursively node.left. So if you are calling the function recursively for the root node, observe here carefully. Suppose initially 3 is my node, LH is equal to height of this node. Again, for example, this 1 is the root node, LH is equal to height of node dot left. In the next iteration, height of 2. Next iteration, height of 3. Next iteration, height of 4. LH is used for calculating the height of left subtree. Similarly, RH is used to calculate the height of right subtree. Now, recursively, I call these functions. Now, what I am doing if checking the conditions. LH, if the equal to LH is equal to -1 or right high is equal to -1. If any of the cases, if it is equal to -1, I am returning that corresponding value -1. Suppose here my condition is the difference is not more than 1. Here the difference is either positive or negative. That is the reason what you are doing, calculate absolute. You got the point? Absolute, the difference LH minus RH. Suppose if the difference is -1, not a problem. The difference between left subtree and right subtree -1, not a problem. Left subtree and right subtree 0 is not a problem. Left subtree and right subtree +1 is not a problem. So that is the reason I am calculating absolute. It always return the positive value. If that value is greater than 1, the value is greater than 1, then I am returning -1. Then I am returning -1. You got the point? Why here -1? For example, assume the point carefully. Here, right subtree is -1 means there is no right subtree. Only left subtree is present. So the difference is now more than 1. Now, final thing. After checking all the conditions, you need to return the maximum height. You need to return the maximum height, the maximum of left height, comma, right height. Whatever the value you are getting, +1. Why +1? You need to include the root node also. After coming out, return the final answer. Return. So here I am calling the function height of, what they are given? Root, height of root. If it is not equal to -1, obviously if it is not equal to -1, return true, otherwise return false. Directly I am checking the condition while returning the answer. You got it? See, accepted. Now submit. See, accepted or not? Now again, observe the program carefully. Here, for example, 1 is the node. Here, first time I am calling height of root, height of 1. Now, if node not null, okay, LH is equal to height of node dot left. So, for 1, what is the left node? 2. So, I am again calling the function with 2. Again calling the function with 3. Again calling the function with 4. And then the left side, 4 left side is null. If condition is failed, then I stop. By this, I am getting LH. Similarly, you are getting RH value. Remember, each and every time LH is incremented. That is, if you are calling recursively, it moves to the left or moves to the right. It moves to the left or moves to the right. That is not a problem. That is not a problem. If the difference is greater than 1, then you need to stop. Okay, this is the program of balanced binary tree. Thank you.